Hey everyone, today we'll be looking at trig with right triangles, specifically angles of elevation and angles of depression. So let's take a look at our first problem. So Jamal stood 4,800 feet from a rocket launching pad. He measured the angle of elevation as 73 degrees when the rocket was at its highest point. If Jamal measured the angle of elevation from a height of 5.5 feet, find the greatest height that the rocket reached. So let's go ahead and take a look at this. So I'll first want to make a diagram of what's occurring here. So we have Jamal standing there, and he's looking up. And we have created a right angle. All right, so it says that 73 degrees, which is right here, 73 degrees, that's our angle of elevation, right? Because that's the measured angle of elevation that's given in the problem. Okay, so next we know some more information about this. We know that Jamal is standing 4,800 feet from the rocket. So we'll go ahead and label this. The bottom is 4,800 feet. And we need to find out this height, I'll call h, the height that the rocket reached. All right, so Jamal's height to his eyes is 5.5 feet. His height to his eyes is 5.5 feet. All right, so we can look at this situation and use our trigonometric function of tangent, right? Because tangent will help us out. Here we get the opposite over the adjacent. Opposite over adjacent. So we'll take tangent of 73 degrees, which is equal to the opposite, which is the unknown h, over the adjacent 4,800. All right, so then inserting the tangent of 73 degrees into a calculator, we'll get 3.2709. And you can put that over 1 to make this problem a little bit look a little bit easier for you, because now once it's over 1, that left side, then you have a ratio equal to another ratio, which is a proportion. And you know that to solve a proportion, we could just cross multiply. So we cross multiply 1 times h is of course h, and then cross multiply the 3.2709 times 4,800. That'll get us, plugging that into the calculator, around 15,700.32 feet. All right. And then don't forget that Jamal's height to his eyes is 5.5 feet. So we're going to add that. So don't forget to add that 5.5 feet to what you just found. So then this gives us a total of 15,705.82 feet. So it is 15,705.82 feet above the ground. All right, let's take a look at our next example. It states that a Navy recon crew was flying a rescue mission in a helicopter. A member of the crew spotted a boat that was in distress. So the crew member was looking down at about a 25-degree angle of depression. If the helicopter was about 300 feet above water level, how far did the helicopter have to travel to be above the boat? All right, so let's first draw a representation in a quick sketch of this whole entire situation. So they were flying a rescue mission and they spotted a boat in distress, and then they looked down at an angle of depression. So here would be the helicopter flying. Okay, so they're looking down at about a 25-degree angle of depression. And understand that the drawing can be a bit exaggerated, but that's okay. So it forms a right triangle. And here's that 25 degrees, right? And here's the boat that was in distress, all right? So 25 degrees is the angle of depression. It also said that the helicopter was 300 feet above the water level. The water level is down here. So 300 feet would be that distance, 300 feet. All right, so now what we need to do is find out how far the helicopter had to travel, that horizontal distance. So we'll call that D. Okay, and looking at this situation, I can use the opposite and I can use the adjacent side, opposite and adjacent side. So I'll use tangent. So the tangent of 25 degrees is equal to opposite, which is 300, over adjacent, which is the unknown, the letter D. All right, and maybe applying some math that we know. After plugging in for the tangent of 25, we'll get 0.4663. Putting it over 1 equals 300 over D. So the math that we know is to cross multiply. So we can cross multiply 1 times the 300 and 0.4663 times D. All right, so we get 0.4663 D equals 1 times 300 is 300. Dividing both sides by 0.4663, we get the value of D, which is 643.36 feet. All right, so this is the distance from the helicopter to the boat, that horizontal distance they would have to travel through the air to be right above that boat.